So block 4, electricity and magnetism. And in this topic, in this block, the subtopic is the electrical working. In this topic, we'll discuss about the power and energy related to electricity. So electrical working, electrical power and energy. Basically, what is the concept of electrical power or even any kind of power? Power is a how much energy transfer every second or work done in a unit time. So if you want to calculate the electrical power, what is the formula? The power is a product of voltage and current. So you have seen like on the cell or on the lamp, basically it is labeled a lamp is there's a 30-watt lamp, a 40-watt lamp, 80-watt lamp, 100-watt lamp. So what does it mean? Like if I say a lamp is having a power of 100 watts, so it means it consume 100 joules of energy in 1 second. So how much energy the device consume every second, that is known as the power of the device. So higher power rating means it will consume more energy every second. So if I have a 100-watt lamp and I have 200-watt lamps, so which one will consume more energy every second? Two lamps are there, one is 100 watt, another one is 200 watts. So which lamp will consume more energy, a 100 watt or a 200? A or B? So which one will consume more energy every second? The power of the device refers to how much energy it consumes every second. So 100 watt means 100 joules every second. 200 watt means it will consume 200 joules of energy in 1 second. So B will consume more energy every second as compared to that of A. So greater the power of the device, greater the power of the electrical component, it means it consumes more energy. And how to work out the power, how to calculate the power? The power is actually a product of voltage and current. So if I say I want to find the power of this lamp or a bulb, so what I need a voltage. So to get the voltage, how we get the voltage? We connect a voltmeter in parallel. So when we connect a voltmeter in parallel, we'll get the voltage. To get the current, we get an ammeter or connect an ammeter. In series. So if I say there was a 2 ampere of a current and a 6 volt was there, because voltmeter shows a voltage across that component and ammeter shows the reading of the current. So what is the power of this lamp? How we can work out the power? So power is a product of voltage and current. So voltage was 6 and the current is 2. So 6 multiplied by 2, it is 12, and the unit of the power is watt. So it means this lamp consumed 12 joules of energy. It consumed 12 joules of energy every 1 second. So how much energy consumed every second, that is known as the power of the electrical component, which can be calculated by using a product of voltage across the component multiplied by current which is passing through the component. And if we want to find the resistance, how to get the resistance? Resistance is actually a ratio between voltage and current. So voltage divided by current give us resistance. So what will be the resistance? The voltage is 6 and the current is 2, so 6 divided by 2, that is equals to 3 ohm. So resistance is 3 ohm, whereas power, like 3 ohm means it has a tendency, low resistance, 3 ohm is a low resistance, so it has a tendency to resist or stop the charges, low resistance, compared to a very high power is about 12 volt. 12 watt means it can consume 12 joules every second. And if we want to find the energy, how to get the energy? Because we have the formula that the electrical power is voltage divided by current. And if you remember in general physics block 1, we discussed that power is also energy divided by time. So if we need energy, if we need this energy, it will be power multiplied by time. So we can say energy is power multiplied by time. And in electricity, because the power is a product of voltage and current, so we can say voltage multiplied by current multiplied by time. What we will get? We will get energy, where V is a voltage which can be measured by a voltmeter, I is the current which can be measured by ammeter, and T is the time which can be measured by a stopwatch. So when we multiply all these three factors, voltage, current and time, we will know how much energy is consumed by the device. So example, there's an electrical fan which is having a voltage 230 main, means that's the voltage, and the current is flowing, that is point, this is the current. At what rate? Rate of electrical energy means they're asking for power. At what rate energy transformed by the fan? So how to get the power? The power is actually a product of voltage into current. So voltage multiplied by current 230 multiplied by zero point 0.4 will get 92 watts. It means every second this will consume 92 joules. And to get energy, how much energy transformed in 1 minute? Whenever time is in minute, you have to convert into seconds. So 1 minute means 60 seconds. And how to get the energy? That is power multiplied by time, or you can also say voltage into current into time. So power was 92 and the time is 60, because 1 minute 60 seconds. So when we multiply, the total energy consumed by this device in 1 minute is 5520 joules. Is it clear? The concept of power and energy, electrical energy. So there are always a straightforward question related to this. Now we'll do some questions related to calculating the electrical energy, power. Whenever devices are using, like transforming the energy, they transform the energy to all, they transfer energy to the surrounding. So example, in the question we have an air conditioning unit like AC is there, the lamp is there, and electric fire is there, like a electric heater. They all receive electrical energy. Like example, the air condition AC is using electricity to work. So the input is electrical for AC. For lamp or a bulb, when you switch on the supply, the lamp start to work. So it is also taking electrical energy. An electric fire or heater, when you switch on the heater, it input electrical energy or taken electrical. So all are taking electrical. But from which of these devices is all energy eventually transferred? But what happens, these devices, they take electrical energy and they transfer all the energy to the surrounding. So any device which take electrical energy eventually, like air condition is there, it is taking the electrical energy and then it blow the air out. So all of the electrical energy transferred to the surrounding. Same thing, electrical heater is there. When we switch on the electrical heater, it consume electrical energy and transfer to the surrounding in the form of heat. And when we have a lamp, it take all the electrical energy and transferred in the form of heat and light. So from which devices all of the energy transferred to the surrounding? Air condition, all of the energy transferred to the surrounding. Lamp, all of the energy transferred to the surrounding. And electric fire, all of the energy transferred to the surrounding. So that's why A is the right answer. Is it clear? So the energy always transferred from electrical to other one. Then there is a current of 5 ampere. So we know the current, and the potential across the resistor is 24. How much energy is transferred in 1 minute? So 1 minute means how time should always be in second. So it's 60 seconds. What is the formula for energy transformed? It is power multiplied by time, or we can also say voltage multiplied by current multiplied by time. So voltage is 24, current is 5, and the time is 60. So 24, which is a voltage, multiplied by 5 multiplied by 60. So this will give us 7,200 joules. So energy consumed is 7,200 joules. Then the average current during the lightning strike between a cloud and the ground is 1.5 into 10 to the power 4 ampere. So that is the current is given. The lightning released 3 exponent 8 joules of energy. That is the energy, and it lasts for like the time which it passes 2 into 10 to the power minus 4. What is the average electromotive force or EMF between or voltage between the cloud and the ground? So how we can work out? Again, we will use the formula that energy is voltage into current into time. So E is the energy, which is equals to voltage multiplied by current multiplied by time. So it is 3 into 10 to the power 8 is the energy. V is the voltage. How much is the voltage? We want to find that, we don't know. Where I is the current which is passing, that is equals to 1.5 into 10 to the power minus 10 to the power 4, and t is the time which is 2 exponent minus 4. So this whole factor is multiplied, other side will be divided. So it will be 3 into 10 to the power 8 divided by 1.5 into 10 to the power 4 and into 2 into 10 to the power minus 4. So when we solve this, it will come out as, because we need a voltage, so voltage will come out as 1 into 10 to the power 8 volts. So whenever you have the energy, current, voltage and time relation, the formula is E is equals to VI T. So because we need V, we substituted rest other values and we got the EMF or the voltage. Voltage can be EMF, electromotive force, or voltage can be a potential difference as well. Another question. A water heater is connected to 230 volt supply. So the voltage is given and there's a current of 26 amperes. So current is given and it takes 20 minutes. Time should always be in seconds. So you have to convert the 20 minutes into second. So 20 multiplied by 60, this will give us 1200 seconds. How much energy is supplied by the heater? So how much energy is supplied? To get the energy supplied, we have the formula energy is voltage into current into time. So voltage is 230. So there should be 230 times the current is 26 times the time interval is 1200. So this will be multiplied by 1200. So when we multiply, it will give us 7 point or 7, this will be big number, 7176, and 3 zeros are there. So we have to convert into exponent because all the answers are in exponent. 0 is here, point is here. So 1, 2, 3, 4, 5, and 6. So it becomes 7.16 into 10 to the power 6. And 7.16 into 10 to the power 6 is approximately equal to 7.2. So D will be the right answer. Is it clear discussion that how we work out the energy consumed or energy supplied by the heater? Then another question. The circuit shows a 12-volt battery. So we have the voltage and it is having a resistance of 3 ohm. So resistance is given. How much energy transferred by the lamp in 2 minutes? So time is 2 minutes, or we can say 120 seconds, because time should always be in second. So to get the energy, we have the formula voltage into current into time. We have the voltage, we don't know the current. So how to get the current? We have first resistance is given. Resistance is voltage divided by current. So resistance is 3, voltage is 12, and the current we don't know. So we cross multiply. This will be 12 divided by 3. So 12 divided by 3, that's equal to 4 ampere. So we get the current to be 4 ampere. Now we can use a formula voltage into current into time. So voltage is 12 multiplied by current is 4. So 12 multiplied by 4 multiplied by time interval 2 minutes or equal to 120 seconds. So multiplied by 120. So it is 5760. So 5760 joules of electrical energy is being consumed by this component. Is it clear, this question? So another question, there is a torch, has a simple circuit with a 3 volt. So this is a voltage and there is 20 milliampere. Milliampere you have to convert into ampere. How to convert milliampere into ampere? Divide by 1000. So it will be 20 divided by 1, because current should always be in ampere. So 20 divided by 1000 is 0.02 ampere. And energy transferred 5 minutes. So you have to convert into seconds. So minute into second, you multiply by 60. So 5 multiplied by 60, that is 300 second. Now we need the energy. The energy is voltage multiplied by current multiplied by time. So voltage is 3. The current is not 20 milli, it is 0.02, because it should always be in ampere. Multiplied by time, which is 300. So it will be 3 multiplied by 0.02 multiplied by 300. That is, when you multiply all the three factors, you will get 18 joules of electrical energy. So B will be the right answer. Is it clear, this question 6? That how we work out the energy? So the formula is the same. You just have to work out according to the question. The table gives data for 4 different electrical devices which develop the greatest power. What is the formula for electrical power? It is voltage multiplied by current. So a car headlight, what will be the power of the car headlight when we multiply voltage with the current? So it will be 12 multiplied by 3, which is equals to 36 watt. Here 110 multiplied by 0.4, that is 44 watts. But what about this one? This is written 400 kilo V. Kilo V means 4000, because this 400 kilo V Kilovolts means it is 400,000 volts. And zero point 0.1 milliampere, because whenever you're finding a power or energy, the voltage should be in volts and the current should be in ampere. But it is written kilo and here is this milli. So we have to convert, like 0.1 milliampere means how much? It will be 0.1 divided by 1000. To convert milliampere into ampere, it is divided by 1000. So this is 0.0001 ampere. Now to get the power, we'll multiply them because power is a product. So it is 400,000 multiplied by 0.0001. So the power is 40 when we multiply. And the last one, 240, that's volt, multiplied by current is already in ampere, so multiplied by 0.2, so that is 48 watt. The question is which is having the greatest power? So when you check, this is 36, 44, 40, but this is having the highest power. The greatest power is actually from the main lamp, as a power is a product of voltage and current, in which the voltage should be in volts and the current should be in ampere. Is it clear? Question 7. Then in question 8, a circuit contain a cell which is having a voltage. This is the voltage of a cell. The current is given and the time is 2 minutes, so it should be in second. So mostly question they give time in minutes, you have to convert into second. So energy is a product of voltage, current and time. So 2 multiplied by 2 multiplied by 120. So 2 multiplied by 2 is 4 and 4 multiplied by 120, that is 480 joules. So D should be the right answer. So these are the questions related to electrical energy and power. Any question or a doubt related to the class today? So I'll end the session and share this with you.